fish tank in the shape of a cuboid is to be made from 1,600 centimetres squared of glass. The fish tank will have a square base of side x centimetres and no lid. No glass is wasted. The glass can be assumed to be very thin. We need to show that the volume of the fish tank is given by V equals 400x minus x cubed over 4. Right, quite a lot of information given in this question. So I'm going to draw a little sketch just to help me picture what's actually happening. So here is my fish tank. Right, it has a square base with side length x, so that's x, that's x. It didn't tell me anything about the height of the fish tank though, so I'm just going to call that y for now, because that allows me to say that the volume of this fish tank is going to be x times y, which is that. We were told that the fish tank was made out of 1,600 centimetres squared, sorry. So that's telling me that the surface area of this fish tank is equal to 1,600. So let's think about that. That's telling me that the base of this fish tank, which has got an area of x squared, plus the walls of this fish tank, so this is going to be x times y, this is going to be x times y, the front of the fish tank would be x times y, and the back of the fish tank would be x times y. Remember, there's no lid, so I don't need to worry about the top of the fish tank. So I know that x squared plus 4xy is going to equal 1,600. Let me make y the subject now, so I'm going to subtract the x squared from both sides and divide both sides by 4x. And I notice that I get some simplification here. The 1,600 divided by 4 is 400. And also the x squared divided by x will just be x. So this is my expression for the height of the fish tank if we're only using 1,600 centimetres of glass. I can substitute that instead of the y here for my volume. So the volume is going to be equal to x squared times 400 over x minus x over 4. The x squared times the 400 over x. Well, this x is going to cancel that squared, so I'll just get 400 times x, which is 400x. We've then got the x squared times the minus x over 4, which will be minus x cubed over 4. And there we go, we've done part A of the question. Make sure you've copied that down. Press pause if you need to, because I'm just going to clear my screen for the rest of the question. Right, part B. Given that x can vary, use differentiation to find the maximum or minimum value of v. So I know maximum or minimum is going to occur when the derivative, in this case dv by dx, is equal to 0. So I want to differentiate my expression. Differentiating the 400x will just give me 400. Differentiating the x cubed will give me 3 x squared, and that's over 4. So I know that has to equal 0 when I have a maximum or a minimum. To solve this equation, let me add the 3x squared over 4 to both sides, times both sides by 4, divide both sides by 3, and if I square root both sides, which numerically would give me 23.09. Now that's the value of x, so that's the side length of the bottom of this fish tank. That's not the value of v, which is what the question's asked for. So I now need to take that value of x and substitute it back into this expression here to actually work out what the minimum or maximum value of the volume is going to be. So 400 times my x value minus the x value cubed over 4 which gives me 6,158 centimetres cubed. So that is the maximum or minimum value of V. To find part C, we have to justify that this value is actually a maximum and not a minimum. So we know that the maximum is going to be when the second derivative, so dv by dx squared, if that is less than 0. So I want to differentiate for the second time, so I'm going to take this expression here and differentiate it again. When I differentiate the 400, it will become 0. When I differentiate the minus 3x squared, I will get minus 6x over the 4. And I want to show that this is going to be negative at this value of x. The value of x we're talking about here is this. So if I substitute that in, we get minus 34.64, which clearly is negative. So I can then say, therefore, a maximum. And we're done.